So these are the formulas of how we calculate the sun's lifespan and how far along it is. Sun's lifetime is equated by energy divided by rate at which the sun emits its energy. Luminosity we know is 3.8 times 10 to the 26, and we're going to put it into Einstein's formula of E equals mc squared. So this is our speed of light, mass of the sun, mass at the core of the sun, and how much energy is disappearing. Energy is calculated 1.3 times 10 to the 44 joules. And when we put it into our big formula up here, energy divided by luminosity gives us our sun's lifetime. But sun's lifetime we have to calculate into the amount of years that it has left. And seconds in a year is calculated by pi times 10 to the 7th. So when we do the sun's lifetime divided by how many seconds are in a year, we know that there's approximately 10.8 billion years in the sun's total lifetime. Right now, it's currently roughly about 4.5 billion years old, and we know that by the moon rocks that we brought back in the 1960s. Okay, so we chose the life of the star, our sun, because it's the closest thing to us, and so it really means the most to all of us on the planet here. Knowing that planet Earth is basically done in about 1 billion years isn't something that we have to be concerned about, but it is something that makes it interesting, and that's why we chose our topic.
Also, the sun provides 99% of the energy for the Earth. So it's a reason we study a lot is because also it's really close to us, so it's the closest star we can study and observe different behavior of stars. And we can also learn from the sun, we can learn how other stars behave.
Yeah, and this semester we've been talking about the HR diagram, and right now our sun's on that main sequence. And so this video just basically shows how the sun is moving into that red giant phase and then basically into a white dwarf.
So right now we know that the sun is on the main sequence, and it's about halfway through the main sequence, and it will continue on for about 4 billion years. And it's burning right now, it's hydrogen, and once that is all burned out, it will start burning through its helium, and it will cause the sun to be more dense and big and luminous, which will move it onto the red giant phase. Once it's at the red giant phase, then the sun will be so big and luminous that it will surpass the Earth and the planets before the Earth and swallow up the Earth, and we will be dead.
I will be talking about the death of our sun. Once it reaches the red giant phase, it'll start coming towards the end of its life. It'll have about 120 million years left of life, which relatively isn't that much for a star. It'll reach the red giant phase, and many things will happen during this phase, such as the core will ignite in a helium flash, where the sun's core and mass will be converted to carbon, not its entire core mass, just parts of it. The sun will then shrink by 10 times, but its luminosity will increase by 50 times, and it will burn out its helium core until it's exhausted. And then it will reach the asymptotic giant branch phase, where it expands again and becomes even more luminous. It'll lose its mass through thermal pulses, which occur every 100,000 years. And every time it does this, it loses mass and its luminosity will increase again. The expansion of our sun will either encompass the Earth or become so hot that life on Earth won't be possible anymore. Other planets might change too. Their atmospheres could change due to the increased heat and whatnot. Once the sun loses half of its mass, its outer envelope will begin to form another planetary nebula.